Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. Complex numbers. In this lecture, I will discuss some important concepts of complex numbers. A complex number is defined as a number of the form x plus iy, where x and y are real numbers and I is unit imaginary number. I is known as iota and the value of I is under root minus 1. For complex number z is equal to x plus iy, the real number x is called the real part of z, and you can write this as real part of z is x. The real number y is called the imaginary part of z, and you can write this as imaginary part of z is y. Just write y, don't write I here. When x is 0 here, then z is iy and z is completely imaginary. Whereas when y is 0, then z is equal to x and z is completely real. Complex numbers are usually denoted by the following letters u, v, w, z, and all these letters are small. In short, we can say complex numbers consist of the form a plus bi, where a and b are real numbers and I is under root minus 1. For example, 3 plus 4i. Complex numbers always exist in pair form. Pair means same signs of real parts and opposite signs of imaginary parts. See, we have same signs of real parts here and the signs of imaginary parts are opposite. So when we have such numbers, then we say the numbers are in pair form. This is the pair of complex number. And we represent if we represent first number as z, then the pair will be represented by z steric. And it is known as the conjugate of z. For example, if first number is 2 minus 2i, then its conjugate must be represented by z steric and it should be 2 plus 2i. Because in conjugates, the real parts have same signs and imaginary parts have opposite signs. So this is the conjugate of this complex number and it is represented by z steric. Well, I already have discussed this thing, that this x means real part of this z and this y means imaginary part of this z. Conjugates. We have discussed this as well. In conjugates, we have same signs of real parts and opposite signs of imaginary parts. For example, if this is z, then its conjugate should be a plus bi and it is represented by z steric. These are few examples of complex numbers. 3 minus 2i minus 3 plus 2i. Well, if this is the complex number v, then its conjugate should be 3 minus 3i, v steric. And the real part of this v is 3, whereas its imaginary part is 3. When we solve a quadratic equation with real coefficients, and if the equation has no real roots, then the answers are in conjugate form. Meaning, if a quadratic equation with real coefficients. Real coefficients means no I in the equation. So if a quadratic equation, for example this equation with real coefficients has two complex roots, then these roots are conjugate. When you will solve this equation, then you will get your answer in pair form. See, negative sign, positive sign, and same signs of real parts. So remember this thing, if a quadratic equation with real coefficients has two complex roots, then these roots are conjugate. When we will solve this equation, we'll get conjugate answers. So by using quadratic formula here, we have this thing. And we all know under root minus 64 will become 8i. And by breaking the LCM, we have z. So we have two answers, one with plus and one with minus. See, these answers are conjugate because we have same signs of real parts and opposite signs of imaginary parts. This is here. Another example, if a quadratic equation with real coefficients has two complex roots, then these roots are conjugate. Real coefficients means no I in the equation. So when you will solve this equation, you will get a pair like this. Under root minus 3 will become under root 3i, and when you will split these two answers, you will get conjugate answers. Another example. When you will solve this equation, you will get conjugate answers. See, the first answer is 0 plus I and the second answer is 0 minus I. But these two equations, when you will solve these two equations, because we have I here and here, the coefficients are not real. So when you will solve these types of equations, your answers will not be in conjugate form. I mean, you will get different complex numbers. You won't get conjugates in this equation and in this equation. You only get conjugates when we have equation with real coefficients. This is very important, real coefficients, meaning no I in the equation. Here we have I here. So the answers of these two equations will not be in conjugate form. And the answer of this equation must be in conjugate form. We already have discussed this conjugate thing. Equal complex numbers. Well, two complex numbers are equal only when their real parts are equal and their imaginary parts are equal. So these two complex numbers are equal only when these two are same and these two are same. If x is equal to a and y is equal to b, then we can say z1 is equal to z2. We can use this fact in this example while solving this question. See, the question is solve this equation. So we just need to write this 0 as 0 plus 0i first, and then we need to equate a real part with real part and imaginary part with imaginary part. So 2x plus y is equal to 0 and y minus 5 is equal to 0. So we have these answers of x and y. Calculations with complex numbers. We have to understand how to add, subtract, multiply and divide complex numbers. So if this is z1 and this is z2, we can easily add these two complex numbers by collecting all like terms. We just need to add real part with real part and imaginary part with imaginary part. Just collect all like terms. So the answer is 10 plus 2i. This is 10 and this is 2i. Same is with subtraction. Just need to collect all like terms. 2 minus 8 makes minus 6 and 3 plus I makes 4i. Multiplication is simple. You have to do a multiplication in the way as you do in real numbers. You just need to multiply 2 with whole bracket first and then 3i with whole bracket. So 2 times 8 makes 16, 2 times minus I makes minus 2i, 3i times 8 24i, and 3i times minus I is minus 3i square. And you all know I is under root minus 1 and I square is minus 1. So we have to replace this I square by minus 1 here. So finally we have got this answer, 19 plus 22i. So there is no problem with addition, subtraction and multiplication. Division, this is very important. When we divide two complex numbers like this, z2 upon z1, we have to remove I from denominator. So whenever we have I in denominator, we have to remove it by rationalizing the whole fraction. So in division, we do rationalization. Rationalization means remove I from the denominator. And the method of rationalization is multiply and divide this whole fraction by this denominator with opposite sign. Divide and multiply the fraction with the opposite sign of denominator's expression. We have 2 plus 3i here, so multiply and divide this whole thing by this fraction. Same denominator with opposite sign. Now we just need to multiply these two and these two. This is a plus b and a minus b, so a square minus b square, and here you have to do simple multiplication. You need to multiply 8 with this whole thing first and then I with this whole thing first. So 8 times 2 makes 16, this is minus 24i, this will be 2i, and this will be 3i square. I square is minus 1. So this will become minus 3. Let me correct this. This is 3, just 3. Plus 3i square will become minus 3. This is here. This will become 9i square and then it will become plus 9. First it will become 9i square and then it will become plus 9. So 4 plus 9 makes 13. So by breaking the LCM we have this answer. Always give your answer in this form. X plus iy. Always break the LCM. So this is the way to simplify this fraction or do division in complex numbers. Another example, express this into this form, and this form is x plus iy. Again we have to do a rationalization. We have to multiply and divide this whole fraction with 1 plus 3i and 1 plus 3i. Same denominator expression with opposite sign. Now just multiply these two and these two and you'll get this answer. Another example. Here you just need to multiply this whole fraction by, multiply and divide this whole fraction by 2i and 2i. So simplify this and this. So this is the answer in this form. So this is the way to do rationalization in complex numbers. Well, in real numbers, a minus b, a plus b will become a square minus b square. But in complex numbers, a minus b and a plus bi will become a square plus b square. Why? Because I square is minus 1. So always use this formula in rationalization. For example, if we have 2 plus 3i and 2 minus 3i, we can directly write 2 square and 3 square, like 2 square 4 and 3 square 9. So the answer is 30. And here is the logic. 2 square, 3i square, this will become minus 9. So 13. Check this again. In real numbers, this result is a square minus b square. But in complex numbers, this result is a square plus b square. Because I square is minus 1. So you can directly write this as 4 and this as 9. 13. And here is the logic. 2 square and 3i square. 3i square will become 9i square and I square is minus 1, so 30. In this question, we have to prove this thing. I'm not discussing this part. I will discuss this part in my next lecture. In modulus and argument lecture, I'm just discussing this part, the rationalization part. We have to prove that 1 upon z is constant. Here is the solution. This is z. See, the value of z is 1 plus cos 2 theta and I sin 2 theta. So we have to rationalize this fraction to remove I from denominator. And for rationalization, we need to multiply this whole fraction with this same denominator but with opposite sign. Multiply and divide. See. Same denominator expression with opposite sign. Now we just need to simplify this. This entire thing will come here and this will become a square plus b square. I'm mentioning this here. A square minus I square and b square. Now you have to replace this by 2 cos square theta. This is the formula. Cos square theta is 1 plus cos square theta is 1 plus cos 2 theta upon 2. So 1 plus cos 2 theta is 2 cos square theta. So we replace this by 2 cos square theta. Now we need to expand this sin 2 theta. Sin 2 theta will become 2 sin theta cos theta and the simplified form of this here. And this is the simplified form of this. Now we need to take common 4 cos square theta from denominator. And this is 1. Now we need to replace this by 2 cos square theta. So by breaking the LCM of this fraction, we have half here and this thing here. Now check. This is the real part of 1 upon z and this is constant. And this is what we had to show. You can check the solution again. First do rationalization, then write this thing here and here use a square minus b square formula. Now replace 1 plus cos 2 theta by 2 cos square theta here and replace this by 2 sin theta cos theta. Simplify the denominator, take common from denominator, this will become 1, replace this by 2 cos square theta and then break the LCM and get the real part of 1 upon z, which is half and which is constant, and this is what we had to show. Well, I will discuss modulus and argument in my next lecture, inshallah. I hope this lecture will help you to understand the basic concepts of complex numbers. Good luck. Allah Hafiz.